Good morning, everyone. This is a video on the numerical practice session of electromagnetic induction, and here we'll be discussing more questions. This will be your question number 6 if we continue from the previous class. So, here is the question: Two conducting circular loops of radii R1 and R2 are placed in the same plane with their centers coinciding. Find the mutual inductance between them, assuming R2 is very less than R1. Okay. So, two conducting circular loops with the what same plane with the centers coinciding. So this is R1, right? This is R1, and this is your R2. Okay, this is R1, this is your R2, and their centers are coinciding. Means they have the same center, right? So find the mutual inductance between them, assuming R2 is very less than R1. Okay, so they are saying R2 is very less than R1. Okay, so R1 is very greater than R2. So we have to draw it. This is wrong diagram. Okay, so we can draw it like this. This is a R2, which is very less than R1, isn't it? As I have said in the question. So this is your R2. This is your R2, and this one is your R1. This one is your R1. All right. So two conducting circular loops. These are two. Okay. Find the mutual inductance. What do you mean by mutual inductance? Mutual inductance means simply, for example, this is a coil. This is an inductor coil. This is another coil. Okay. So if current passes through one coil, okay, so what will happen? There will be magnetic flux change with in the other coil because of this current. So due to the magnetic flux change in the other coil, there will be current or induced EMF in the other coil. Okay, that is a mutual inductance. Mutual means one is giving rise to the other. Okay, current is flowing through it. It is like magnetic flux is changing through the other coil, and current is induced in the other coil. Okay, so exactly here, see, because of R1 and R2, because of this like mutual inductance means, for example, current is flowing in the R1, because of that induced current is being produced in the second one. All right. Okay. For example, otherwise it can be also the other direction, like other way around. If current is flowing in R2, then induced current will be produced in the R1. Okay. Suppose current I is established in the outer loop. For example, this is your current I. Okay, this is your current I in the outer loop. Okay, so what will be the magnetic field because of it? We have to write the magnetic field, isn't it? We have to write the magnetic field because of it. So if I write the, oh sorry, if we, sorry for the diagram. Okay, I'm not good in diagrams. Okay, if we write the magnetic field for this one, what is the magnetic field for a circular loop? If I write the original formula, mu naught I divided by 4 pi r1, the radius is r1, 4 pi r1 into phi. What is phi? Phi is your angle in, this is not flux. Okay, I'm just writing like the angle that the loop makes at the center of the uh, that one, the curve. Okay, so here it is making 2 pi, isn't it? It is making 2 pi. So I will put that 2 pi here. Mu naught I by 4 pi r1, mu naught I by 4 pi 4 pi r1, and this is your what, 2 pi. All right, this is your 2 pi. So 2 pi and 4 pi, they cancel each other out, it becomes 2. So b is equal to what? So b is equal to what? B is equal to mu naught I. B is equal to mu naught I by 2 r1. Okay, so this is a what? This is a magnetic field because of the outer loop. Okay, magnetic field because of outer loop. But what do we need? We need the flux, right? But we need the flux through what? Flux through this one, inner coil. isn't it? We need the flux through inner coil. Okay. So how do we find the flux? Flux is phi is equal to what? Magnetic field into area. All right. So magnetic field into area BA cos theta, but here cos theta is not there. So BA theta can be zero because like they are concentric. Okay. So B is this one mu naught I. B is mu naught I by 2R1. What is A? A here is the area of the smaller loop. Okay, flux through the smaller loop. So pi what? Pi R2 square. Okay, pi R2 square. So this is a flux. Okay, this is a flux. So can you tell me the relation between flux and mutual inductance? We need to find mutual inductance, right? We need to find what? We need to find we need to find mutual inductance. What is the symbol for mutual inductance? M. Okay, so M is equal to what? The formula for M is phi by I, if you remember, flux by current. Okay, so phi by I is what? How much? Mu naught I. If I put the value of phi here, mu naught I by 2R1 R2 square from the previous slide, all divided by I, right? So I will be cancelled out. So what will be the answer? Hmm, sorry, I missed it. Oh yeah, there is a pi here, pi R2 square. Yeah, I will be cancelled. So mu naught pi R2 square whole divided by 2R1. Okay, whole divided by 2R1. This is your mutual induction. Sorry, mutual inductance. What is the unit of mutual inductance? Can you tell me? What is the unit of mutual inductance? Unit of mutual inductance is Henry. Okay, unit of mutual inductance is Henry, isn't it? So mutual inductance and self inductance would be Henry. Yeah. So yeah, this is the question again. Not that hard. It's just you have to use the concept. Like current is flowing through the outer loop. Okay. So magnetic field will be because of the outer loop, and flux we will calculate over the inner loop. Then only we can calculate the what? Mutual induction, inductance. Sorry. Okay. Yeah. So yeah. If you have any doubt, you can ask me in the comment section about it. Okay. Next question. A conducting loop of area 5 centimeters square is placed in a magnetic field which varies sinusoidally with time as B is equal to B naught sin omega t, where B naught is given 0.2 Tesla, omega is given 300 per second or 300 hertz, whatever. The normal to the coil makes an angle of 60 degree with the field. Okay, with the field. Find the maximum EMF induced in the coil. Okay, the EMF induced at tau is equal to this, and the EMF induced at t is equal to this. Okay, so try. I am giving you 2 minutes. At least try this question. Okay, and then we will discuss it. Okay, see. Okay, still solution. See. Conducting loop of area 5 centimeters square. So we'll write down all the data that is given in the question. This is a what? 5 centimeters square. 5 centimeters square. Okay. Is placed in a magnetic field which varies sinusoidally with time as B is equal to what? B is equal to B naught sin omega t. Alright. B is equal to B naught sin omega t. Where B naught is also given. B naught is given how much? B naught is given. B naught is equal to 0.2 Tesla. Okay, B naught is given 0.2 Tesla. Omega is what? Omega is equal to 300 per second. 300 second inverse per second. The normal to the coil makes an angle 30 degree. Sorry, 60 degree. So theta is equal to 60 degree to the field. Find the maximum EMF induced in the coil. Okay. First of all, what is EMF? EMF is equal to minus del phi by del t, isn't it? Minus del phi by del t or d phi by dt, whatever. So phi is what? We know phi is b dot a, that is ba cos theta, right? Ba cos theta, and theta is how much? Omega t, isn't it? So ba cos omega t. Just see how I'm approaching the question. Okay, you need more practice to have that approach. Okay, otherwise you won't be able to approach the question. Ba cos omega t. So if I put the value here, so it is d del by del t of what? Ba cos omega t. Del by del t of Ba cos omega t. Okay. Del by del t of Ba cos omega t. So Ba can be taken out as it is a constant, minus Ba, and del by del t of cos omega t is how much? Minus sin omega t. Minus omega sin omega t. Minus omega sin omega t. Alright. Minus omega sin omega t. So minus minus becomes plus. So our EMF becomes how much? Ba omega. Ba omega. Am I doing it correct? Okay, okay, wait. No, no, no. Let's do one thing. Let's do one thing here. Because B is also given, na? B is also given B naught sin omega t, right? Okay, so I think we have to put it here. Okay, I think yeah, we can cut it. No problem. This is not the right way. Okay. So what will you do? See, why I did that? Because the theta is given here, right? Theta is 60 degree. So I can put theta directly here, isn't it? Cos 60 is 1 by 2. But B is not, we cannot take B out. I did a mistake here. See, the mistake is I took B out, but I cannot take B out because B is a function of time. B is equal to B naught sin omega t, isn't it? So I cannot take B out. Alright. So that is wrong. I cannot take B out. So what will I do? I will do it again. No problem. These things happen during solving a numerical. Okay, and it's good if it happens. This way you will understand the like what can be the mistake. Okay, so you should also know what can be the mistake. Okay, if you always do correct, then you'll be ignorant of the mistakes. So what will I do? E is equal to minus del by del t. So here what will I do? I will directly put in place of B naught sin omega t, isn't it? Which is given in the question. B naught sin omega t into A into cos theta. I won't put theta as omega t. Cos theta, let's put the direct value. Okay. So minus B naught. What is B naught? B naught is given, right? B naught is 0.2. B naught is 0.2. Okay. Right. B naught is 0.2. A is given, right? A is how much? A is 5 centimeters square. So If I convert centimeter square, that will in meter square, that will be 5 into 10 to the power minus 4 meters square. 10 to the power minus 4 meters square. So this will be 5 into 10 to the power minus 4. Okay. And cos theta is cos 60. Cos 60 is 1 by 2 into del by del t of sin omega t. That is omega cos omega t. Okay. Omega cos omega t, isn't it? Omega cos omega t. So if I do all the calculations, 0.2 into 5 is what? What? It's 1. Okay. And this is 0.5. So it becomes minus 0.5 into 10 to the power minus 4. 10 to the minus 4. What is omega given in the question? Omega is 300, isn't it? So put the value of omega as 300. 300. And cos 300 into t. Okay. So 300 into 0.5 becomes how much? Hmm? It's 50. I think 150, right? Yeah, 150 into 10 to the minus 4. That should be 0.0150. Okay. Into cos 300t. It will remain like this. Cos 300t. So now the question is, how will you proceed here? See, we are asked maximum EMF induced in the coil. Maximum. When is it maximum? If, for example, there is a function x is equal to x cos omega t, or x cos theta, suppose. So when x is maximum, can you tell me when x is x naught? Sorry, x naught. When x is maximum, let's take the like magnitude of it. Okay, magnitude. So all this will be plus. Yeah. Okay, when x is maximum, when cos theta is maximum. Okay, x is maximum when cos theta is maximum. When what is the maximum value of cos theta? 1. Okay, so first bit we will just put this one as 1. So the maximum value of EMF will be how much? E max. E max will be 0.015. What is the unit of EMF? Volt. All right. Now, what is the next beat in this question? Put this is not tau. Okay, this is t. So EMF induced at t is equal to pi by 900. Okay, t is equal to pi by 900. That means 0.015 into cos 300 into pi by 900. Okay, so cos pi by 3. Cos pi by 3 is how much? Again, cos 61 by 2. So 0.015 into 1 by 2. Calculate and uh, get the answer. Okay, calculate this one. And also EMF induced at pi by 600. Again, just you have to put what? In place of t, you have to put pi by 600. That's it. I won't do the third bit. You do yourself. Alright, so this was the again a very simple question. It looks very big, so don't leave it in exam just because it's looking big. Okay, just write down all the data and avoid this mistake. Okay, if b is a function of time, we cannot take it outside. Okay, all right, yeah. So yeah, this question is over. This was your question number 7. Okay, next question. Question number 8. Read the question once yourself and try to solve. Yeah, I'm giving you 2 minutes. Okay, so let's read the question. Which north pole of a magnet? North pole. This is the north pole, right? Magnet is brought down along the axis of a horizontal circular coil. As a result, the flux through the coil changes from 0.35 Weber to 0.85 Weber in an interval of half a second. Find the average EMF induced during this period. Okay, you have to find what E average. All right, is the induced current clockwise or anti-clockwise as you look into the coil from side of the magnet? Okay, can you tell me this one? See, first of all, let's get through the direction. Okay, what is Lenz's law? What is? Oh, sorry, this is not visible. No? First of all, what is Lenz's law? For example, this is a coil. This is a magnet moving towards the coil with its north pole facing towards it. So if the north pole is facing towards the coil, so the coil will produce such a direction of current. Okay, such a direction of current, so that what? So that it will repel the motion of the magnet. So it will produce what? North pole, like this. North pole on this part of the coil. North pole means like this. See, you just have to match this direction. This is a trick to remember. Just do n and just do this thing. So this is which direction? This is what direction? Anti-clockwise. So current will be what? Anti-clockwise on this side of the coil. It's saying as you look into the coil from the side of the magnet. If I am here, my eyes are here. If I look like this, so this will be your what? North pole, isn't it? This will be your north pole, right? Yeah. So this is over. This one is gone. Find the average EMF induced during the period. That is easy. EMF means simply what? EMF means simply d phi by dt. Okay, the magnitude d phi by dt. Okay, d phi by dt. All right. So d phi means change in phi. Change in phi is how much? 0.85. 0.85 minus 0.35, isn't it? 0.85 divided by dt. Dt is what? Time. What is the time here? But half a second in an interval of half a second. It's not. It's written in words. Half a second means just half second. Half second means what? 0.5. So instead of 0.5, let's put only half. So 0.85 minus 0.35 is 0.5. Okay, and that 1 by 2 from denominator will come up into 2. So this becomes what? 1. Okay, this becomes 1 volt. Don't worry about like average EMF, all that. It's just the same thing. Okay, 1 volt. So this is the answer, 1 volt, and the direction will be what? Uh, Anti-clockwise direction. Okay, again, this was a conceptual question. Okay, yeah. Okay, let's move to the next question. Next question, this one. Question number, what is it? Question number 9. Read the question first yourself. Uniform magnetic field B exists in a cylindrical region of radius 10 centimeter. Okay, as shown in the figure. A uniform wire of length is given, resistance is given. It bent into a square frame. This is a square frame. Is placed with one side along a diameter of the cylindrical region. If the magnetic field increases at a rate of this one, find the current induced in the fan. Okay, yeah, I'm giving you 2 minutes. Try this question. Okay. So if you haven't solved it yet, you can pause the video. A uniform magnetic field B, okay, exists in cylindrical regions of radius 10 centimeter. Let's write down whatever is given. So R is 10 centimeter of that circular loop. Resistance is given, uniform wire of length 80 centimeter. Okay, length of the wire is given 80 centimeter. Okay, 80 centimeter. Resistance R is given 4 ohm. 4 ohm. Okay. So, is bended square frame is placed with one side along a diameter of the cylindrical region. If the magnetic field increases at a rate, magnetic field increases at a rate. At a rate means I told in the previous video with respect to time. So dB by dt. Okay, dB by dt at a rate. You can also guess from the unit Tesla per second. That means B by T or dB by dt. So 0.01, but Tesla per second. 0.01 Tesla per second. Okay. So this is one. Okay. Now what? What is asked? Find the current in the current induced. Current means what? I. You. We have R resistance. So if we can find EMF, we can find current is equal to E is equal to IR. Okay. So EMF is how much? D phi by dt, isn't it? EMF is d phi by dt. Your phi is what? B into A. Okay. Phi is B into A. So here B is, we can take A out. Okay, A, we can take A out because A is constant, and dV by dt. Here area is constant. Okay, area is not changing. It's not say like it is moving or something. Here magnetic field is changing. Area is not changing. Okay, what is the area? What is the area here? Magnet. This one is 0.01. Okay, what is the area here? Can you tell me? See here. Yeah, can you tell me? See, exists in a cylindrical region of radius this one. Uniform wire of length is bent into a square frame is placed with one side along the diameter of cylindrical. Magnetic field increase at a rate of this. Find the current induced in the frame. Okay, in the frame. That means we have to find the current wire in the this square frame only. So which area we need? We need only this area because magnetic field is through the circular region, yes, but the we have to find the current in the frame. So what part of circular loop is inside the frame? Only this half part. So we have to write what the area is, what pi r square by 2. Did you get it? Did you get it? Why not pi r square? Why not pi r square? You can say pi r square, all the magnetic field is inside here, pi r square. No, because what part of the circular loop is inside the frame? Because current, we have to find current induced in the frame, in the square frame here. Where is it? Square frame. So what part of the circular loop is inside the frame? Only the half, this half circular part, semicircular part, that is pi r square by 2. Okay, got it? Yeah, don't do the mistake. You will do the mistake. You will write a is equal to pi r square, I know, but this is the concept. This is the difference of this question. Why did I do the question? If it was only pi r square, what was the difference? Okay, so this was the reason I did it. Okay, so pi r square by 2. All right, now just nothing else. 3.14. Put all the values, you will get the answer. 3.14 into r square. 10 centimeter convert into meter. All right, so 10 to the power minus 1 into minus 1 square, that is 10 to the minus 2. This is 10 to the minus 2 all divided by 2. Okay, so this is what? This is your EMF. Whatever you will get, this is your EMF. So current is what? I is equal to V by R. So EMF by R. EMF is also kind of voltage. So EMF by R. You will get the value of current. Okay. Current you will get. I'm just writing the answer. Current you will get 3.9 my sorry 3.9 into 10 to the power minus 5 ampere, or what? 39 microampere, you can say. 39 microampere. Okay, this is the answer. All right. Yeah, this was again not hard. just have to be cool during the question. You have to read it properly, where you have to find the current. Hmm. Don't just do blindly like pi r square. Okay. Yeah. Let's move to the next question. Suppose the ends of the coil in the previous program, okay, connected to a resistance of 100 ohm. Neglecting the resistance of the coil, find the heat produced in the circuit in 1 minute. Okay. This is question number 10. Try this. You have 2 minutes. Try this question. Okay, okay, wait. I think I haven't given the my bad. Okay, I haven't given the previous question. This is not the this one. Okay, this is not this question. This is a different one. I haven't given it. Okay, my bad. I think haven't uploaded. Anyway, no problem. Okay, this much questions I think will be enough to for you to for the revision of electromagnetic induction. Okay, so so what things you will keep in mind while revising electromagnetic induction? So things are Faraday's law. Okay, Faraday's law, Faraday's law of electromagnetic induction. Then your what Lenz law, isn't it? Lenz law, important questions. Lenz law. Then what? Then you must be able to solve the flux questions, like flux and EMF type questions. These are the most asked questions, most number of asked questions in the exam. Okay, and also the directions of current, isn't it? How will you find the direction of current from Lenz law? Okay, north pole, south pole, direction of, they will ask you the polarity. Polarity means north pole or south pole. Okay, direction of current. Then what? Then mutual inductance, self inductance. Okay, those things also mutual inductance, self inductance are also important. All right, yeah, and unit conversions are there. Then if yeah, the energy formula, that energy formula we did yesterday can have variety of questions. U is equal to half Li square. Okay, U is equal to half Li square. And if current is like is changing, like I is equal to what? I is equal to I naught 1 minus I is equal to I naught 1 minus e to the power minus t by tau. This is a very important formula. Okay. Yeah, you just have to put it here. For power, if the this one is changing, for power it is du by dt, isn't it? Du by dt. Okay. For maximum power, what we'll have to do? For maximum power, dp by dt is 0. Okay, dp by dt is 0, and whatever value you get there, you will just put the value in the p. Okay, yeah. So yeah, this type of questions can come from this chapter. Okay, if possible, we'll do more questions in the next session. Okay, more advanced questions from this chapter, which will help you in other exams as well. Okay, yeah. Just let me see what extra thing is there that I have left. No, this much only. All the concept, all the questions will come around from these concepts only. Okay, so you keep revising, keep do this all the questions again if possible. Okay, yeah. Okay then, that's it for this class, and I will see you in the next session. Okay, yeah. Thank you very much.